Hi, everyone. Welcome. Thank you for joining us. I'm Bennett Grubbs, APSA Associate Director of Teaching and Professional Development. On behalf of APSA, I'd just like to welcome you to today's workshop, Incorporating R and LaTeX into Political Science Research. This is APSA's Committee on the Status of Graduate Students. Hold on, sorry, I'm going to admit some more people. So this is APSA's Committee on the Status of Graduate Students in the Profession's fifth event of their workshop series that they started this year. Today's event is being recorded. It's published on the Graduate Student Committee's website, where you can also find recordings to their previous 4 professional development workshops. This is going to operate in 2 parts. So we'll have a presentation followed by some Q&A, and then the second presentation again followed by some Q&A. The presenters will stop at points to allow sort of some questions as we go, as well as have questions at the end of each presentation. You can also use the chat function to just sort of post questions, and we'll help facilitate that. And lastly, I'd just like to say that we ask all webinar participants to adhere to APSA's Respect campaign. The Respect campaign encourages professional respect by and towards all APSA event attendees and participants at all times. Respect stands for respectful, equitable, safe, professional, and ethical conduct towards all. You can learn more about this and APSA sexual harassment policy on our website. So with that, I'm going to turn it over to one of the committee members, Laura Uribe, and she's going to introduce one of our facilitators for today. Thank you.
Thanks so much, Bennett, and hi all, and welcome to this space. My name is Laura Uribe. I am a PhD candidate over at UC San Diego, and I'll turn it over really quickly to Kelsey to introduce yourself.
Hi, everyone. My name is Kelsey Osborne Garth, and I am a third-year PhD student at Michigan State University and co-chair of the Committee on the Status of Graduate Students.
Thanks so much, Kelsey. And I'll go ahead and introduce Derek. So like Bennett said, we'll have a short presentation. Feel free to interrupt or ask questions as you go, followed by a short Q&A. We'll follow over with Ali. So Dr. Derek Wakefield is a Post-doctoral Fellow at Emory University. He works on projects related to Latino voting behavior. He received his PhD in politics and social policy from Princeton, and he specializes in American politics, political behavior, political communication, and political psych, all about Latino politics. Derek's taught this class before, so he's gotten good engagement in the past. This workshop, you'll learn how to start coding in R. That means understanding the workspace, the R Markdown environment, and a set of packages that will help you navigate the process. He'll then apply these skills to make tables and figures that are commonly found in poli-sci research. And the goal of this workshop is just to give you that basic foundation, that tool set that can help you introduce you to the world of R. So I'll pass it over to Derek and I'll set a timer. Thank you.
All right, wonderful. Thank you so much, Laura. I'm excited to be presenting here. And yeah, without further ado, so I'm going to be doing a lot of jumping between different screens, so apologies for the confusion. I mostly have control over it though. And I will say that I'm generally not going to be able to see chat, but I will do my best if people have stuff that they want to be clarified. Because I really think this topic is one that in many cases you have to sort of learn on your own, but you also, at times I think that the third time you see something, it clicks. And so for many of you, this is the first time you're going to see it. If you're confused, don't worry. I was confused the first time I did R, and I did the entire Hadley Wickham textbook, and I went to an R class and I was still confused. So for those who this is maybe their third or fourth time, or they're more intermediate, some of this might be a little bit basic, but please bear with us as we all enter this wonderful journey of quantitative data. So before we go any further, because you can do this in the background, install R and R Studio. They both have to be installed separately. They're 2 separate programs, although you'll primarily be using R Studio for reasons we'll talk about in a bit. The link is right there. Please let me know if there's any issues. Choose any mirror. And again, have that going on in the background while I talk. We'll have about 5 minutes before we start actually applying some of this. So it'd be great if you have R ready by then. So what is R? R. Sorry, I can't hear any of you laughing, but I'm assuming that you are all cackling hysterically and making your roommates uncomfortable. But in all seriousness, R is a very, very powerful and common coding language for social scientists. And the main benefit is that it is free and open source. That's also some of its downsides, but I think as time has gone on and R has really become the workforce of particularly social science computing, its open source nature and the fact that it's free means that it's always accessible, easy to edit, and something that once you figure out some of its quirks is actually quite powerful and can do a lot of different things. So it's effective at analyzing large data sets, even as large as 20, 30 gigabytes. There's R packages that can do stuff that's even bigger than that with parallel computing. It's also very, very effective at making visuals that communicate data analysis. And also some of the fundamentals of R translate pretty effectively into other coding languages, especially Python, but also JavaScript and LaTeX, which we will be talking about in the next presentation. So whenever I talk about R, I pretty much stop whoever is talking to me and go, have you used tidyverse? Are you familiar with dplyr? These words don't make any sense or mean anything unless you're familiar with them. If you're familiar with them, I don't think R works without them. And so these two packages, and we'll talk about how to load packages in a bit, but especially the tidyverse universe of packages is just so key to doing a million things in R that, you know, you can maybe do it some other way, but most of the time you're going to take 2 to 3 times as long. And also a lot of these open source packages are built on the tidyverse universe. The other benefit of tidyverse is that there's a free textbook by Hadley Wickham, who is the author of tidyverse, that is essentially one of the best, again, open source and free ways to learn R. Also included in tidyverse is the dplyr package, which basically creates a language. I've had 2 entire lectures on this. And just to note that most of the Hadley Wickham textbook is in the tidyverse space. And then ggplot2 is really great for making clean looking plots. So we're going to start bouncing over between these two. So for now, I'm going to put this to the side. Okay. So when we're looking at the R package here, the R program, so you all probably have this open up. And if you don't, again, you can just follow along. And I would even say that following along at a later date could help. So the top visual bar, there's a lot going on here. You really don't have to know most of this. Really, it's going to be going to here. You're going to do new files. And I almost always use either R Markdown or R Notebook. I'll talk about that in a little bit. But beyond that, what's really important to know about R is that it has multiple windows that show all these important pieces of information. Something that you'll do a lot is you'll have your coding window in one separate, and then you have data and output on the other. And you can manipulate that by using this little show a new window. Over here is called the data environment. And one thing to note about R is that R basically works as an object-based data coding environment. So this means that what R is doing is you tell it to save or load a certain kind of data. You are then doing transformations on it. And that data exists on your hard drive. You can even see up here, this will show as much space as you have free. Sometimes if you're working with a data set that's bigger than the number of RAM you have, it literally won't load. And so this is a really nice way that R in many ways opens up the black box of computing and lets you get into things like optimizing. We don't have to worry about that right now, but just know that there's a lot of helpful information here. And everybody has their own way of organizing. I also tend to like the dark themes more. But so whenever we're starting a new file, so I've already done it here, but this is what you all will do. So start a new file, and I would do an R notebook. I always just delete all that because nobody cares about it. And then here, what we're doing is called creating a chunk. And one way to think about this chunk, that's like a paragraph. So here, the first chunk that I have in any kind of coding project I'm running is a library load. I have some of these where this is a list of 20 library loads. And oftentimes when you're getting into much larger projects, you want to have just an entirely separate file that loads all of your libraries, which is called an R project. You don't need to know about that. For you right now, start with this .rmd file and load these two. And require is important because instead of simply saying library, which requires you to have it already installed, require will install it for you if you don't already have it installed. And then note that every R chunk starts off again with this triple left apostrophe. You always have to put the letter R in lowercase. This is what tells R Markdown that this is using the R environment. One way to think about this is that R Markdown is a wrapper function for having you put code. And then here you're saying using the R version that I also have installed separately, run whatever code is here. And so again, at the start, you're always going to load what's important. And also in general, whenever you're doing things such as having a workspace, you want to have a single folder. So note here that I'm saving everything into this single folder that we have here. And basically anything that I would do with this project would end up in this folder. Don't put it in your downloads or documents folder, it'll get lost. What you want to do is to have it saved into one spot. And again, for some of those, I'm repeating stuff that you already know. I have so many problems that come when people don't do this. And then at the very beginning, so this is saved again in that folder. And then when we go to the session, we can set the working directory to source file location. And what that does is it means that anytime I'm telling R to load data, it'll automatically look to that folder, so that workspace. And so ultimately, I would say that always keeping your projects and all of your files in a single folder that's saved somewhere separate from your documents or your downloads folder in its own separate folder. This will help keep your coding much cleaner. And so R can do a number of basic commands. So really basic addition, 1 + 1, subtraction, all of them. Some that are also more important when we think about really large data sets are things like means. So if we were to, for example, try to calculate here the mean of 1 through 5, which would be the numbers 1, 2, 3, 4, 5, the number will come out to 3. We can also use sum, which same deal. So if we sum the numbers 1, 2, 3, 4, 5, we get 15. But note here that we're not actually saving this as an output. So right here, this is just sort of a number that's just off in the ether. If we want to save data, we have to do what's called this assign caret. I call it a caret because it looks like a carrot. You can use equal signs, but don't use equal signs. Use the caret. And here what we're doing is we're saving small data as the number 9. And we can see here that if we were to call this small data, it'll return 9. And we can manipulate it, and this will report 10. But note that what we just did is not actually changing fundamentally what this variable is. Same here if we exponentiate. So if we take 9 to the 1/2 exponent, which just means take the square root, the answer will be 3, but we're still only saving it as 9. If we want to save it, we have to either overwrite it or create a new data object. So here's small data 2. And if we multiply it by 2, we can see that it is now being saved as such. And sorry, I know that I have a few audience comments. So once we get at the end of this chunk, I will then take a step back and go over some of these things. And so whenever we're talking about data objects, they're always stored here in the environment. Very rarely are going to be working with things as small as individual values. So what's more likely is that you're going to end up having, for example, a vector. And this vector here, what we just did was we created vector 1, which what this is saying is R, create a new data object titled vector 1, and then create, and right here, this is just called a column command. R, if you just do this, R doesn't know what to do with it. And this is just one of those weird things about R. Anytime you're creating, and you notice it here too, anytime you're creating a list, you have to put a C in front. And what that means to R is this is a column of data. And we'll talk in a little bit about what this means to have an XY format to your data. This is a 1 dimension. So it's 1 dimension vector 1. Vector 2, also 1 dimension, length of 3. Vector 3, also 1 dimension, length of 3. Now, if we were to try to merge together vector 1 and vector 2, it doesn't work. And this is because the number of rows is different. And so R in general will break before it does things that really messes up your data. So instead of creating bad output, R will oftentimes return an error. And so it's something to note that if your code doesn't run, it's usually for a good reason. There's some kind of mistake in there. And so in this case, whenever we merge together vectors 2 and 3, those do go together because they are the same length. And then if we were to open it, and so here we can start to get a little bit more into what the data looks like. We can see here how R is actually interpreting vector 2 and vector 3 both as columns of length 3. And then the way that R is then associating this is here is observation 1. For vector 2, it's 4. For vector 3, it's 1. Here's observation 2. For vector 2, it's 8. For vector 3, it's 2. You can do this by looking at this, or by clicking, literally it's clicking, or you can just use the command view. And then finally, tibbles are just generally cleaner. You don't need to worry about those right now, but you will oftentimes see tibbles being used, especially in data that doesn't have massive, like more than 10 gigabytes, just because tibbles are just generally an easier data type to work with. I don't have the time to explain it, but just trust me on that. Okay, so I'm now going to take a step back and try to open it up for those who had questions. I'm sorry, I'm trying to get my meeting controls back. Okay. Yes, everything will be available after the workshop. Everything will be loaded. Oh, and none of these are being shared with you. So actually what you can do is literally type what you have here. The data sets that I'm going to be using are also all completely publicly available and already come with R. And so hopefully you all are able to literally just type the code that I have here. This is not going too in-depth. So if this is too much to follow along, I would say after this video is posted online, watch it a second time and do the entire code with me. Okay, are there any other remaining questions on just this overall idea of integers and R, vectors, and how we then build data sets? Okay, so then we're going to move on. So we're going to work with the data set called the cars data set. So here we can firstly just see that cars actually literally comes preloaded with R. So if we were to just view cars, we see is a list. It's two variables, speed and distance. And it's actually pretty cool. It's a list of cars from, I want to say, the 1930s. So pretty, rudimentary, but cool data. But then if we want to save it, so note that cars doesn't exist in our data environment yet. So if we want to save it, we have to reassign a new data frame. And just for convention, I almost always name my data frame _df, just so that I can keep track of this as, if you have a million data objects, you want to know which ones are data frames, which ones are lists, which ones are names, maps, all those things. If you want to get details about this too, the question mark command with basically anything allows you to then look and get a bunch of good data. And so here it's not super complicated, but oftentimes, especially with packages, this question mark is the first step for finding documentation. You can also use names. And so what this gets us is a list of names, which with this data frame isn't that big of a deal, but imagine you had a data frame with 12,000 columns. You don't want to have to open up the viewer. It may actually literally not open up. But okay. I wanted to work with a slightly more fun data frame. So this empty cars data frame has a bit more going on. So this one is from 1974, and we can see here that it includes many more variables. And actually what's kind of nice about this exercise is some of them I would say are not coded properly either. So what we're going to do for the next about 10 minutes is go through these. We're going to make sure that the data is clean, and we're going to show the consequences of either not cleaning your data or cleaning your data on how you eventually present data analyses. So when we're first just looking at this data frame, we can use the glimpse command, which lets you get sort of a head. You can also use the head command to get the opposite, where you're just looking at the first few variables and then a summary. The issue is that the bigger that these get, the bigger your data frame is, the less helpful these kinds of functions are. Because it's just really hard to work with this kind of output. And so what I do, and I call this my group by and reframe trick. So don't worry for now about what's going on under the hood here. Because in large part, a lot of this is going to be stuff that you will learn when you eventually read the R for Data Science by Hadley Wickham textbook yourself. Pipe operators. So what these mean is and then. So let me just read this through in English. R, I want you to create a new data frame, diag _ data frame. We are going to, whatever we are doing here, save it to that data object. We're going to take the cars _ df data, which again is right here. And so the pipe operator is just sending that data forward. We're going to group by this cylinder variable, which from the question mark, we know refers to the number of cylinders in the car. Send that forward. So now the data is grouped by cylinders. And then we're going to reframe. And this count reframe is just a very basic way to get a descriptive. Oh, whoops. And then we can see here. So in this data frame, there are 3 kinds of cylinders, so 4, 6, and 8 cylinder cars, and then there's 11, 7, and 14 of them respectively. And this is just a really important check because, for example, let's see that there was maybe a 0 cylinder car. I hope not, because it wouldn't run. Or maybe we have a, I don't know, a 7.5 cylinder car. Maybe there's some kind of new technology we're not aware of. Or even worse, there's an NA here. If any of those are true, if either there is data that doesn't make sense, that could be miscoded, or that is NA, you have to go through and fix it. And that's another topic, so I won't get into that too much, but just know that this diagnostic check of your data is really, really crucial so that down the line you don't run into problems. So we're also going to be analyzing horsepower, so we'll do the same thing. And note here what I'm doing. I'm actually overwriting my diagnostic data frame because I don't want to have a million of those clogging up my environment. So basically, anytime I'm doing work, I just have this diagnostic data frame open, or oftentimes in a second monitor, and I'll just go through. Now let's check. Okay, now it's good, man. Doesn't look too, nothing's weird here. And I just cannot reiterate the importance of understanding your data, because I really think that human beings are not good at this. Our brains are not meant to understand data sets with more than about 100 observations and more than 50 variables. It just is not something that we are equipped to do. And so I think having these diagnostic and wrapper functions is really, really helpful so that you don't have issues in the data that you then can't address. Okay, are there any questions then on the basic idea of cleaning data here? Oh yeah, for data frame is for when you're using large data sets. Tables are generally cleaner and more data, more efficient with smaller data sets. There's not huge differences between the two though, so I just use tables by default. Usually if your data is smaller than 5 gigabytes, you can use a tibble just fine. And dplyr also works with tibbles, and so it just tends to work better. Functionally, they're 98% similar. Okay, so we'll keep on moving. So with plots, you can use base R. And so here we're just doing a very basic XY graph where we have miles per gallon and cylinder. And that's, again, if we think about this diag, I didn't put miles per gallon here, but we're essentially just saying, show me the relationship visually between these two. And we can see how this is in the viewer. Sorry, right here. This is another reason why I use R Markdown and chunks, is that it allows you to see output directly below your code. But as we can see here, super ugly. We're not even gonna look at it anymore. We're gonna use ggplot. And the reason is, firstly, ooh, ah, so pretty. But also from a clarity standpoint, there's just a million things that ggplot has done. They're trained data and visual scientists. They do things that are smart that you could spend your entire life trying to do. So I just think ggplot makes your life a lot easier. There's also a bunch of additional packages. And so one of the ways that ggplot works is by creating layers. So what I'm saying here is, okay, ggplot, we're gonna make a graph. The data is gonna be, again, this car's data frame. And for every single layer, I want the x-axis. And for this first call, it's important to do this for your x and y-axis. Otherwise, you literally will not have those in your plot. So on the x-axis, put the number of cylinders. And on the y-axis, put miles per gallon. And then I want you to plot a point. So that point is going to firstly take the aesthetics. So the x will be the cylinder and the y will be miles per gallon. And then the color, I want you to take from the type of transmission. And so we get this output. But I'll say that even this is not quite ideal. For example, again, we don't have 5 or 7 cylinder cars. And also this AM, this automatic transmission, is currently being coerced into a continuous variable. That's actually incorrect. So you can't have a semi-automatic, I guess you can, but in this case, it's automatic and manual cars. I'm really showing that I'm not a car guy with this. But so firstly, and also one other thing I want to note, these variable names for people who do not know this data, not helpful. So do not present at your seminars a plot that has the original data codes. And the way that I tend to fix this is not by coercing a lot of the labels after the fact. I actually go back to the original data and I create new variables that have both the proper names and the proper levels. And so what I'm doing here, I'm not even overwriting my old data. I don't feel the need to overwrite that old variable, but I'm creating a new variable here, cylinder. And again, this will look cleaner. And also what I'm doing is I'm saying, just create a factor variable and order it from 4 to 6 to 8. I don't want to get into this too much, but generally, if you're ever doing a visual presentation where you have a discrete and fairly small number of variables, for example, if you're presenting results for white, Black, Latino, and Asian respondents, you want to create a factor variable. You want to decide on the order of that variable, and that will keep it consistent for the reader and also for regression outputs in the future. Because as we'll see, what we're doing here is we're saying that 4 is the baseline category. And so down the line, we'll see, especially with regressions, why this is a helpful thing to do. Because otherwise, R is actually interpreting these as 4.0000 to infinite and allowing for this to potentially be a numeric. We don't want it. We want it to be really understanding this as 4, 6, and 8 as qualitatively different, not as quantitatively comparable. And same here, we want to make the transmission more clear. And so again, based on the documentation of empty cars, we know that the AM variable is where they save automatic, and 0 equals automatic, 1 equals manual. So I'm creating a new variable again, and I'm adding it to the existing data frame. And so what this is doing to this cars data frame, I'm adding variables to the right-hand side. I'm not removing any, but I'm adding them to the right-hand side. And this then keeps things very simple for the future. We don't have to really do too much when we eventually plot these. And then I'm doing an if-else statement. So what the if-else statement does, and again, please, this PowerPoint and all this code will be shared online. You should go over it with a fine-grained comb. I'm blasting through it so that we can cover everything. So this if-else statement starts off with a logical statement. So here I'm saying if AM equals 0. So again, if AM is equal to 0, which means it's automatic. Oops, I miscoded that. See, this is why it's always important to check these things.
Derek, just wanted to let you know that we are at the 25-minute mark. So if you want to, thank you.
Yeah, we're actually very close to the end. So this is great timing. Okay. So what we're doing here, we're just cleaning all this up, and we're also renaming MPG to MPG. And then here, firstly, we can just see that the labels are cleaner. We no longer have those weird 5 and 7 cylinder monster cars. We also have a clear label for whether the transmission is automatic or manual. This is just a first step. I will say that most of your data analyses are going to do a bit more coercion of the data to get means and other things. But I hope that this is helpful for knowing how to do a basic ggplot. And again, clean your data before you analyze it. Don't try to clean it by fixing the labels function. Okay, so we're going to go through regressions real quick here. So the idea behind a regression is, and this is going to be a review for many of you, but you have 2 variables that you're trying to figure out how they're correlated. And so in this case, my question is the horsepower related to the number of cylinders in a car? And so here I'm using the original cylinders variable, and I'm calculating a regression. Again, data equals cars df. The left-hand side, you can also use the formula equals, but you don't have to. And I'm saying predict the horsepower of each individual observation based on the number of cylinders. In the next model, I am then adding this automatic transmission. And so one way to think about this is, once we have accounted for the effect of the number of cylinders on a car's horsepower, what is then also the effect based on its transmission? And then I use Stargazer, which is just a very, very straightforward function. You put in your LM objects. I have it kind of have a type text output. And what this does is it actually saves it into that workspace. Sorry, y'all. Right here. And so I'm not going to interpret that because you all will do that in your stats courses. And in the sake of time, I'm not going to get into it. But I want to note that the regressions, and this is maybe some homework for you all, why are these regressions with the old data not as effective as those with the more cleaned data frames after. And I'll leave you all to ponder that question so that we can open the floor to Q&A. And just some very last thoughts. I tend to not use R Markdown. You might have, especially in your stats courses, problem sets that use R Markdown. But most of the time, I'm using an R Markdown or R Notebook file to create tables and figures, and then I go into LaTeX or I go into Microsoft Word and PowerPoint to then produce the full manuscript. So just note that that's my process. Different people have different processes. I don't find R Markdown as helpful for producing academic research. I think that LaTeX is much more appropriate for getting that kind of output. Yeah, so I'm just gonna highlight this. Yeah, you know what? Just screw the rest. Just read that book. Okay. And yeah, any other Q&A, and I'm happy to open the floor.
Thank you so much, Derek. Yes, and I see in the audience, if you have a question, go ahead and raise your Zoom hand and we can process questions. Like, we'll try to budget like 8 minutes or so. And then Derek, I'm sure we have your information. We can send out if folks have any additional questions. So if you have a question, please go ahead and raise your hand. Thanks, Narek. Go ahead. Or Narek.
Hello, can you hear me? Yeah, okay. Thanks again for this, by the way. I found all this stuff really, really helpful. Really quickly, so I guess my knowledge on R isn't like the best, but I did have a question about when we're kind of going over the automatic kind of example with the ggplot. So I've kind of ran into that similar problem myself, where it was kind of viewing my values as sort of, I forgot the term that you used, but sort of like from 0 to 1 when it wasn't exactly like that. And I had used manual scale to kind of fix that. I was wondering for that specific ggplot problem, if there was a way that it would be possible to use that as well, or if it work for that one, because I haven't used that specific ggplot graph yet.
Yeah, the simple answer there is you should turn it into a factor variable with 2 levels. And ggplot and R. So actually, I'm going to open up this because there was a question about interpretation. So like if we were to interpret this right here, I don't really know what's going on here, to be quite honest. And this is using the old data. And to your point, what's going on with that AM variable? I forget. It's not clear to interpret what any of these coefficients mean. But then whenever we're using the clean data, which here what we're doing, we're firstly using 4, 6, and 8 cylinder as separate factors, because what I'm assuming is that going from 4 to 6 and from 6 to 8 is not this numeric thing. So that's what R was doing in this old output, was that R was assuming that going from 4 to 6 would be the same as going from 6 to 8, which theoretically is incorrect if you're a car guy, or car girl, car person. But then also looking at this transmission manual, this is now even more clear. So what this is saying is the comparison is transmission automatic. So the omitted category in this regression is transmission automatic. It's not shown, and talk to your stats professor about that. The interpretation here is that on average, a manual transmission car has about 36 higher horsepower compared to an automatic transmission car. And then when you're thinking about also, and also here's my reasoning for first having the bivariate, and this gets to the interpretation question. So I really strongly believe in looking at simple XY relationships and then adding control variables. So you don't want to be throwing everything into a model at once. And so if we're just simply interested in, okay, if we have a 4-cylinder versus a 6 versus an 8-cylinder car, what are changes in the horsepower? And then here you can say, compared to a 4-cylinder car, 6-cylinder cars have 40 more horsepower on average, 8-cylinder cars have 126 more horsepower on average. And so I hope that also helps answer the interpretation question as well. I was very careful to clean my data in such a way that I can literally say things like, based on this coefficient, there is this change. in the horsepower.
Thanks so much, Derek. And that answers, I think, William's question in the chat. I'm going to go ahead and give you 3 more questions, and then just to be mindful of time. Someone asked advantage of R compared to Stata. Someone else asked, can you change in the markdown file R regressions to something like Python? And then Elizabeth's question, migrating our output to LaTeX. I might leave that over to Ale. Ale will be covering LaTeX, and so that's a
You
beautiful.
just do this, and then you put it into your LaTeX file. It's great. So yeah, great question on the R output. It's literally just an option in Stargazer. Outputs in LaTeX. Put that in your file. Does great.
R versus
Sorry,
Stata.
I skipped so Stata is paid for and has a lot of functions that R now has. Stata is limited in its ability to use more than one data object. And so I think they're comparable, and you can do basically the same thing with both. Stata just costs money and is not, in my opinion, as flexible as R. So I would recommend learning R if you have a choice, but like they're both fine.
Thank you. Someone else asked, and someone thumbs upped it. Recommend any resource about web scraping in R?
Yes. Honestly, I would look up, like, this isn't helpful, but there is a really great online module on web scraping that's like 14 chapters, some odd things. Like, that is like, whenever I was scraping Twitter, I had a friend do it for me because it's very complicated. It's the kind of thing that, like, whether it's web scraping or geospatial analyses or massive data sets of like 100 gigabytes, that ends up being like a 2-month-long project where you really just have to do your homework and find where that is. Luckily, R has so many resources. So I don't have an exact reference off the top of my head, but R for data science has a link to a lot of these extra topics, and web scraping is definitely one of them. I would recommend just going to whichever one they recommend.
Thanks so much. And then Yen asked a similar question to Elizabeth. The process of running these regressions, creating these tables, and then how to put that into a manuscript for submission. So I think it's that same LaTeX.
Yeah. Once you do this, you leave R. So this would be my advice: is use R to output. And I save this, as you can see, as a dot text, or should I save it maybe as a dot text? It gets a little bit finicky. But as we'll see in the LaTeX portion, like, you really don't want to be having to play around with this too much. And R does a good job at outputting. And you want to do basically in Stargazer, there's also a bunch of commands for like title equals, ylab equals, and you just want to do all of that beforehand so that your output is then consistent and clean. And I would just go to the Stargazer package to get more information on that. The other reason for the Stargazer package it's really important is that journals almost always want and Alejandra will get into this more, almost always wants your figures to have text that can be searched, which means that you should not be submitting tables or figures that are a PNG. You want it to be something that can actually be put in line with the article, which this output, specifically the second bit, LaTeX output.txt, gets you what you need. And then for figures, I just save them as a .jpeg or .png, depending on, that just depends on compression.
Thanks so much. And then one last question before we transition over. In PolySci, is there an advantage to using Tableau or Power BI as opposed to ggplot?
What I'll say is that once you're getting out of base R, it's hard to go wrong. I'm not as familiar with Power BI, but I've used Tableau a bit with some Shiny apps because it's a little bit better for stuff that people are working with. Yeah, I've enjoyed it. So I would say ggplot is for creating. Basically, if you have to create a figure, you should use that's not interactive. I think ggplot is the best. But some other packages are better if you have things that have to be modified on the fly, because ggplot can sometimes take a bit of time to calculate.
Thanks so much, Derek. And if you could just please share that PowerPoint again so folks can see where they can contact you on your website. And then thank you so much. Thank you for fielding all the questions.
And also tell your departments to hire me.
And I'll pass it
Thank you all
on.
for having me.
Thank you, Derek. I'll pass it over to Kelsey.
Awesome. Thank you so much, Derek, for that. And guys, if you have any questions, please feel free to reach out to Derek. Now we'll turn to the LaTeX and citation management and how that can really benefit you and how that works seamlessly with R. So I want to introduce everyone to Alejandra López Villegas. She is a PhD candidate in political science at Michigan State University. Her research examines democratic backsliding, gender and politics and their intersection, with a regional focus on Latin America. Methodologically, she is interested in quantitative methods, particularly text analyses and survey experiments. Ale is also on the job market, so if you know of any departments hiring, please also tell your departments about her. And as someone who learned R and LaTeX from Ale, she is a phenomenal teacher and you will learn so much from her today. So I'll turn it over to Ale.
Okay, hi everyone. Thank you, Kelsey, for the nice introduction, and thank you, Derek, for your good intro to R. I am hopeful that because you covered some things already, it will be a bit easy to transition into that. But okay, let's get right to it, and let me share my screen. Okay, so we're going to be covering how to write with LaTeX using Overleaf and R Markdown. And so the first thing that we'll do is understand what LaTeX is. Then we'll understand how to use LaTeX using online editors such as Overleaf. Then we will understand bibliography management with Overleaf. And finally, we will try to understand how to incorporate LaTeX and R Markdown. I am hopeful that time will allow us to do all of these things. But yeah, I think I will echo a lot of what Derek said in that there are a lot of online resources into whatever you want to do. And it also takes a lot of trial and error to get these things right. And so do not be afraid to make mistakes. Yes, R will tell you error and you'll be frustrated, but then I think it's part of learning how to do good data analysis. And so do not be discouraged by it. There's tons of resources online, and overall, I think it's a very supportive community to learn how to do all of these things. So resources like Stack Overflow, Stack Exchange, probably if you're running into an error, that means that someone else already had that error, and someone online probably already answered that question. So do not be afraid to Google things. You can just literally copy paste your error into Google and something will probably help. But yeah, now going back into the workshop. So what is LaTeX? So LaTeX is a typesetting system that produces technical and scientific documentation. And we use it a lot because it is very standard to communicate and publish scientific documents. If you were using a word processor like Microsoft Word, it's great, but it's not as shareable. It's not as customizable. I don't know if you've ever had the experience of putting an image and then your document becoming crazy, and then it's very hard to get back to what you had before. And so the reason why we like things like LaTeX is because you can actually track how these changes are made and then go back in them. It's also why we like to use systems such as R rather than just a simple Excel spreadsheet and do the analysis there, because you can actually keep record of what you're doing and identify where mistakes are being made. So yeah, it's good to document everything you're doing as you're working on things. But yeah, LaTeX is also very useful to write math equations. You can also make presentations. You can also create your CV, make posters, etc. And there are many editors that call command line tools. So just like R, what Derek was doing was typing out commands. And so LaTeX also works using commands. It's just a different language, but it's pretty simple. And yeah, so for Windows, basically the ones that I would recommend to install is either MikTeX or TechLive. And then for Mac, there's MacTeX and CTeX. And then my favorite personally is Overleaf, because Overleaf is an online system that allows you to edit in LaTeX, but it's pretty shareable, it's customizable, you don't have to run it locally on your computer, it's just a web page, and it's really nice. So going back to Overleaf, it's just an online LaTeX editor that will make your life easier because it doesn't require you to download any software. And it's also awesome for collaborative work. If you're working on a co-authored project and everyone's working on the same manuscript, Overleaf is sort of like Google Docs in that it allows you to see what your co-authors are doing, but it's just that you're writing it with like specific commands that we will be going over. So now, what does a LaTeX document look like, regardless of whether you're using like Overleaf or something like MikTeX? There are two parts to every document. One is the preamble, and the other one is the body of the document. And so, in the preamble of any LaTeX document, you set up the packages, and you also want to define the properties of the document. So, in the preamble, you will specify if you're working on an article, if you're working on a presentation, if you're working on something different, and then you will also call all of the packages that you will be using. So Overleaf has specific packages. It's similar, well, not Overleaf, but LaTeX. It's like R in that if you want to put in a figure, you will need to have a package so that the LaTeX compiler can actually read that command. And so there are many like packages that you can use. But yeah, you can also have your header, who's the author, what is the title, what is the date, etc. And then basically, yeah, it's everything that would go in your document before you actually start typing out the actual content of your document, which is then the body. And basically, in the body of the document, you have where all of the text and code will be compiled. And basically, you will always want to begin with this little command line, which is /begin document, and then you will end it with /end document. And so yeah, we will be going over an example, so don't worry if right now this all seems very abstract and weird. But yeah. Now here I added some tips for your documents, just because I know that these are things that are very common and that we all want to use. So here I have like you would use like a double / or /new line to move whatever follows into a new line. So like if you want to create separate paragraphs, you would use this command. Then /new page will jump to a new page in the actual document. So if you want to indicate to the document, hey, do a like jump from this page to the next one, you would type in new page. Then here I have like how to make quotations because it's not like the usual double quotation mark. And then what I find the most useful is actually creating like sections and subsections so that you can actually keep track of your document. And so you can start with like section, and you will have section 1, and then you will type subsection, and you like inside of the curly brackets is where you will write the title of each section or subsection. And here I have an example of like what it will be producing. And then also here I have like how to add in a footnote. So if you do like if you're typing a paragraph and you want to add a footnote before a sentence ends, you would just do /footnote and then curly brackets, and inside the curly brackets you would put what would go in the actual footnote, but then it's like clearly referenced in your text like where that footnote goes and what it will say in the end. Here I also have a little framework of how to do lists and how to create like bullet points, because that's also something that we're very interested in doing. And so for this, we will use this framework called begin itemize. So you're creating like an itemized list, and then each item is each of your bullet points. Same thing if you want to create like a numbered list, you would write /begin enumerate, and then each item will be each of your like items for your list, and they will be numbered automatically. You can also play around with the spacing. For this, I like to use a package called setSpace, and from there you can use two of the like. There are many ways to do the same things, but you can either use double space or single space, or you can also use this command, which is like /setStretch, and inside the curly brackets you would type in the desired spacing. So you can type in like a 1 if you want it to be single spaced, or a 2 if you wanted it to be double spaced. Then you can also have tables, which will always also have their own environment, and they work with the ampersand command, which creates the content of each cell, and then lines always end with 2 /signs. Don't worry, I will be going over an example in a bit. So Yes. And then as Derek was mentioning, once you learn more R, if you create some tables in R, there are lots of packages that are really nice and really useful. Derek showed you Stargazer, but Model Summary is also a very popular one just because of how easy to manage it is. And basically what this does is that if you type in that command in R, it would automatically give you some LaTeX code that you can then copy and paste into your LaTeX document. And so that table will be forever pretty. It will not be separated. It will not do the annoying thing that Word does, that it's like making lots of jumps or maybe formatting it in a weird way. But yeah, we'll be going over an example as well. You can also add some figures, which for this, you will use the GraphicX package, and then you will just begin figure and then end figure. And here you would add the figure that you're going to be putting into your document. Another thing that is super useful is that you can write out mathematical equations. I don't know if you ever tried to write a math equation in Word, but it's very annoying because you have to be you have to create little cells for each mathematical symbol, and in that sense, it's pretty hard to do, but LaTeX does this in a very easy way. And I have an example for this in my Overleaf file, but here is a list of, like, I tagged in some online resources that I think are super useful. Here is a list of the commonly used symbols and like what the code for calling them is. So for instance, if you want to write like a beta, you would have to type out /beta. But yes. And then finally, for like citation management, which we all love, you also can get LaTeX to produce your citations, and so your list of references, without you having to do this. And so to do this, you just need to create a .bib file. We will be going over what that is to store your references. And then you tell LaTeX how you want those citations to appear on your document. Finally, another important note is that you need to use a bib package, such as netbib. But from there, it's very easy to call citations and to have your document have a nice list at the end with the bibliography. And so, yeah, the bib file is a flat text file that has a series of lines for each entry, and you can refer to them in your main document. So I have an example, and so I think it's better if we do that by example. But yeah, some cool things that I don't have time to show you, but that I want you to know exist, is that you can use your citation manager, such as Zotero, to create your bib file to export all of your references to BibTeX. And here I am also linking a good guide for how to do this. And then if you refuse to use a citation manager and you want to like keep track of each of your citations, Google Scholar is also really nice for this. And I will show you how to do this in the example. So now let's go to Overleaf. So Overleaf, as you see, it's just like a website called overleaf.com. Here I'm already logged into my account, but here I have my article, or like my document for today. And so, oh, sorry. What I was showing you earlier is like all of these, like before this command line, which says begin document, this is the preamble for my document. And so here I am specifying that I am writing an article. Then I am saying that I want to use the GraphicX package because I want to insert an image. Then I am specifying that I am going to be writing some math equations, and so I also need a package for that. Then I am also using the setSpace package to set up like the spacing between lines. And finally, I am using the netbib package, and that is for my bibliography. Then I am creating my title, which is APSA Workshop. I am the author for this, and then we have our date. And then we begin our document. So this is this is where the body of the document will start. And so I call begin document, and then I am using this command that is make title. And so this automatically will put the title, which is APSA Workshop, my name, because I'm the author, and then the date. For instance, if I deleted this, I am going to comment this out. You can comment things out in LaTeX using the percentage sign. But yeah, if I did that, I would just if I didn't call for the title, it just starts with the actual introduction, which I don't want. I want there to be the title and for it to show that I am the author and today's date. And yeah, and now I am creating my first section, which is like introduction. This is the command to create the new sections, but if for whatever reason you didn't want to have a number, like if you didn't want it to say number 1, you can always put an asterisk before you start the curly brackets, and then that way you can just have introduction without it being number 1. Another cool thing about Overleaf, what it automatically does is that if you look here at the file outline, I have each of my sections and subsections. And so if I wanted to jump towards the end, I would just click on it and it sends me toward the end of the document. But yeah, so going back into our introduction, the first thing that I want to go over is like writing some very basic math equations. So let's say that we want to type some math, which is 2 + 2 = 4. This is very basic, and because of this, like we perhaps may not need to use like a fancy command line to actually write it. But as things get more complicated and we start using Greek letters, we probably will want to do this. Or also if you want to create like subindexes or create some like fancier things, if you want to like do a division, some things like that, you will see that it's a lot more convenient to actually use these command lines to write math equations. And so to do that, to indicate that you're starting a mathematical equations, you want to use the dollar signs. And so you would start with a dollar sign, type in your math equation, and then end with another dollar sign. And so this seems very simple, right? You have like 2 + 2 = 4. But just something that I want you to note is that if we compare it to the one we wrote before, this one already includes spaces between each character. And so it's a bit cleaner. It's a bit friendlier to the eyes, especially if you have a very long math equation. It'll be great if you can actually, like if you can see those more separated. And then, yeah, let's say that we want to write something more complex, like our very basic OLS function, which is y = β0 plus our first beta times x, and then plus our error sign. And so that requires a lot of like the use of a lot of Greek letters. And then this is when it would get very annoying to type this out in Word. And so to do this, what I did is that I started with my dollar sign, I ended with my dollar sign. And so this, what is inside here is my equation. And so here I have my y, my dependent variable, and I am subscripting it to each I, equals my first beta 0. And here, once again, using the lower hyphen, I am specifying that it's beta0 plus beta1 times x, subscripted by I for each observation, plus epsilon to indicate the error sign. And so now we have a very pretty math equation here. I just had like, you need to be looking for how to do specific things. If you want to do fancier things like how to add an exponential or how to add like a product sign. But these are things that are fairly easy to do, and you would just have to type out these commands. Now, to create a list, I am using the itemized like framework that I showed you in my presentation. So here I have begin, itemize, and end itemize. And then inside that framework, I have each of my items. And so I have item 1, item 2, and item 3. Then to play around a bit with the spacing of my document, here I have like set stretch to 1. So here, wait, why is it not? Yeah, so now it's working. Sorry about that. But yeah, so here I am setting the stretching to be like a single line. But then if I wanted to maybe actually do like double spaced, I will type in here set stretch to 2, indicating that it's double spacing. And here I now have the sample paragraph, which, yeah. But I don't like it. So I'm just gonna go back into like setting like for the rest of the document, I'm just gonna have the single spacing. Now, moving forward, I want to create a table. So this can get a bit more complex, but right now I have like the very basic framework for how to create a table if you actually want to write it out and not just copy paste it from R, because that is something that I do very often, but you may not want to do that. But say that you have like, you would start by indicating begin tabular, and then inside of the curly brackets, you specify the number of columns that you want to have. So here I have 2 columns. And if I had 3, I would simply do another C. that is 3 columns, but right now I just want 2. And then in each line, I will add like the content of each cell. So here I have A, and then I use the ampersand symbol to specify that I want to switch from column to the next one. And here I have B. Then I want to indicate, okay, this line is over. I want to move to the next row in my table. And so I will use the double slash sign. And then to create an actual line between the rows, I use H line. And then I specify C and D, and then I end the table. And here's how this table would look like. It's very simple. It gets a lot more complex, but this is like the very basic framework of what you're doing. I have an example of how to actually paste, like how we could do this with Stargazer if we wanted to get a more complicated one. Now, in terms of like figures, right now I just had like the APSA symbol, well, like its logo. But yeah, and so what I'm doing here is I am starting the figure. And so to do this, once again, like with everything in Overleaf, I have to specify the type of object that I'm going to be using. And so I'm saying begin figure. And then on the side, I just want to anchor it to this part, like to where I'm starting to write. And to do this, I use square brackets and an H. And then I type out the command include graphics, and I uploaded my PNG file here, and then I type out the name of that PNG file. Because this one was a bit too large, I had to scale it down to half of its actual size. But yeah, that's something that you can play around with the size. If you actually want to center it, you can also do like begin centering, and it's pretty customizable as well. And now going back into like our bibliography. So here, let's say that we want to cite like this very famous book, Designing Social Inquiry, which is a book that we political scientists have used a lot. And so I am writing out my paragraph regularly, like, oh, blah, 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 blah. And then I need to specify that I am citing something. There are 2 ways in which you can cite, which is very common for like publishing articles. You can either want to like cite in text, which means that you have the last name and then the year in parentheses, or you can want to reference it at the end of the sentence and have parentheses, last name, comma, year, parentheses. And so you can use either citet or like cite T, which is like to cite in text, and then cite P, which is to cite like in the paragraph, and that generates like the the parentheses. But yeah, and so basically now I like, and where I got this King design thing, I got it from my bib file. My bib file is separate from my actual document, and it's here on the side. So I generated this document called bibliography.bib. If I wanted to do this like from scratch, I would do new file, bibliography.bib. This is going to be confusing a bit for Overleaf, just because I have 2 files that are called the same thing. But then what you have inside of these files is your actual citation. And so this is like the framework that LaTeX uses to generate citations. You need to specify, like you generate a tag, to be able to call it from your main document. Then you have a title, the author, the year, and the publisher in this case, because this is a book. But like, where do I get this? Did I generate it myself? I did not. So if you go to Google Scholar and you go to Cite, BibTeX, you get this little, like, it's already done for you. And then you would just copy that and paste it into your bib file. And that's it. Now you already have the tag. And so if you go to your text and you want to cite something, you would do the command cite T and then your tag, and then, or cite P and your reference, like your tagged reference. Then at the end, I want to specify where my bibliography list will go. And so I actually have to call it. Here I changed the bibliography style. It's like you have APA, you have Chicago, you have many different citation styles. In this case, I chose the APSR one. And then I just called my bibliography by using this bibliography command, and then calling my bib file, which is called bibliography. And so it automatically generates the reference for me. And yeah, and so in the end, you get like this nice document that is pretty customizable. And always, 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 you have to end your document. If you do not type out this last command, it will not compile, and it's something very simple. You just have to make sure within any of these frameworks that whatever thing you begin, it needs to end, because if not, it's very confusing for Overleaf. But yeah, and then if I wanted to share this with someone here, I can send it to like my co-authors if they wanted to edit it. They can also make some comments to it. And so that's why I really like it. And now very quickly, like how to incorporate like LaTeX into our Markdown. So as Derek was saying, our Markdown allows you to compile a single document into different formats such as PDF, HTML, or Word. And it allows you to create notebooks in which you can run chunks interactively. And you can use our Markdown to create slides, write journal articles, generate websites. I also do what Derek does, which is that I just use R to generate my plots and my tables, and I prefer to use something like Overleaf just because that way I can share it with more people. And I also prefer to be on an online cloud, and it's not locally stored in my computer. But if you wanted to write a full journal article in our Markdown, you can do it, and it's pretty easy to do so. Now, your R Markdown documents are like any LaTeX file. They are made up of two parts, which is the metadata, in which you specify the title, the author, the date, and the output that you want to get, and then the body, which is text and code chunks. Here I have a few tips, which I am not going to be going over for the sake of time. I just want to say that whatever is not inside the metadata, so like in the top part of your document, will be a code of chunk or text. And then we comment out commands using hashtags. And here I have like a cheat sheet on how to like modify what is inside your text. So you can create titles, subtitles. Once again, you use the $ for equations. You can also include images. You can also create breaks. And yes, and you can also reference your bibliography file. Here, if you have chunks of code, they will display in your compiled R Markdown file. And so you may want to hide warnings, or you may want to actually hide the chunk of code, but still have it exist. And this is all pretty customizable, and you will do it inside of the curly brackets at the top of each chunk of code. And then
I wanted to, you are at time, but if you want to wrap up really quickly.
Yeah,
so we
it's
just
going to
have
be
questions.
super quick. So then you will compile. And so here I have a very quick example that I just wanted to show you on like how this would look like. If here I have like my metadata, and so here I have the title, the author, the date, and the output. I can do multiple outputs if I wanted to. And then I also have like 2 + 2. We will see what it equals to. And then here, let's run this. And then I get the 4. Then I am using, again, like the cars data set that Derek used. I am running a very simple regression where I want to know if the distance that a car went through is affected by the speed of the actual car. And then here, what I can do, I got this LaTeX code. And so I can just copy paste it. Oh, sorry. And take it to my Overleaf file. And then we can just put it in, let's say here. And so now I have a very pretty table in my Overleaf file. And I just took the code from our Markdown and just copy pasted it. I did it live. So that's pretty nice. But if you still want to use your R Markdown documents, here I will just change the type of output to say that right now I'm just going to compile it to an HTML file. But let's say knit to HTML. And so here I have my document. And so what you can see here is that I have my chunks of code. They are the ones in gray. But here I did a title by using a hashtag. I then wrote my nice math equation. It was the same that I used in Overleaf because it's also LaTeX. And then it actually, because I typed in print, the quick math equation we did, it shows you the output. And then I also have here the table that was generated by Stargazer. But yeah, the quick takeaways from this is that you can do a lot of things with LaTeX. It will make your life easier, and it's also trackable. You can keep up with the changes that you're making to your document. If you don't like the way that something looks, it's pretty easy to change. And another nice thing is that someone online has already gone through the same problem that you did. And so if you just Google your mistakes and get used to making mistakes and not being sure of what you're doing, you can make a lot of progress, and it's part of it. None of us were born knowing how to write in LaTeX, but with like these very basic commands, hopefully you'll get a sense of how to do this on your own for your own articles. But yeah, I am looking forward to seeing if you have any questions.
Thank you again, Ale. How I think we'll conduct this Q&A to make sure everyone can, so we're not doing both chat and in person, is just put your questions in the chat and then I'll read them off for Ale, and then we'll go that way. So if anyone has questions, turning first, Jan, if you want to, did you clarify what your question was, or do you want to clarify your confusion?
I can do that. Can everyone hear me?
Yes.
Yeah, so let me just clarify that I'm primarily a Stata user. I'm new to R. So sometimes when I generate a text file from either Stata or R, it has all the table content, but not necessarily the begin and end. When I don't see the begin and the end, I realize that, oh, R's LaTeX not going to do the thing just because I'm missing some of the procedural code. I'm just curious, whenever I have a standalone text file with a table content, is there a standard set of code that I can wrap this input file with so that LaTeX can proceed with the compiler? Thank you.
Yeah, thank you for your question, Yen. So what I will say is that generally you will need either a template or something to wrap around your table. If you just take the LaTeX code and you plug it into Overleaf or into a text generator, it will not compile because you're missing the preamble and you're also missing the begin document and end document. And so what I do generally, I'm going to go back to sharing my screen, is that I just basically I use the same framework in Overleaf. And so in each project, I just copy and paste all of these packages. I know that I will always begin the document. And the first thing that I do is like begin and end it. And then I know that inside, if I just want to put in a simple table, I can just copy paste it. But you do need like the preamble, and you need to specify the body of the document by using the begin article and document, sorry, and end document. I hope that clarifies it.
Just a quick follow-up. So do we know for sure that model summary and Stargazer always produce a text file with begin table and end table? Is that guaranteed?
So I think so. You can the thing about model summary and Stargazer is that they are super customizable. You can change like the name of the dependent variable. You can change the name of the independent variables. You can omit the constant. If you actually would prefer not to show stars and would rather look at, I don't know, a thing like confidence intervals, you can do that. That is not something that I actually added into my slides, but before I send them out so that everyone can access them, I will put in a quick a link to a guide on how to modify both tables both in Stargazer and model summary. Because you will most likely want to change things inside the table.
Thank you.
Awesome, thank you. So Spring asks, will we also get the Overleaf example that you shared with the specific codes, PNG and bib files?
Yes, I will make sure to send all of that. And as Bennett has been saying, we will be uploading this online, but also you will, if you register for the event, which I assume you did because you're all here and you wouldn't have gotten the same link otherwise, you will get an email with the materials that both Derek and I used.
And then Samuel asked, is there a way to import Word documents into Overleaf, or do you need to copy and paste the text from Word and manually write the LaTeX code?
So unfortunately, I have not found, I have run into this very annoying thing where maybe I have something written out in Word and I want to transcribe it into Overleaf. And so what I will generally do in those cases is, once again, use my standard preamble, start my document, and then copy and paste here, my Word, the content of Word. And yeah, and then generate the tables and do the citations using the commands. I am not sure if we're allowed to say this, but maybe ChatGPT could be a helpful resource. You can, like a nice thing with ChatGPT is that you can upload documents and then you need to say, oh, please write this in LaTeX. And so if you have a Word document and you ask it to write it out in LaTeX, you can get nice LaTeX code, and that may be super useful. The one thing I will suggest is always double check. And so if you're writing out a table and you use ChatGPT to get the LaTeX code and you want to plug it into your Overleaf, just make sure that it looks the way you want it to look, because ChatGPT can make mistakes. But yeah, unfortunately, I don't think there's like an online resource that automatically does it for you accurately. I always do it by hand.
Awesome. And then going back up, I actually think Derek asked, do you use the same template for different papers, or do you modify individual paper/manuscript settings? I almost always just copy paste the preamble.
Yeah, so
Me
as I
too.
was saying, yeah, I do the same thing where I copy paste the preamble. Like in this case, to be fair, I used very few packages just because this specific workshop required very few packages, but I have had other projects where like I use a lot more packages. But I will just copy paste them, and then if I don't use them, it's not a big issue, because like Overleaf is not like, oh, you included a package that you did not use in your document. Maybe the one, like, it will actually change if I am doing like my CV or if I am writing out something else. I'm not sure if this, like, also like doing presentations, it's a bit of a different framework that also requires a lot of packages. But yeah, for instance, here I have my CV. And so here, I have like different sections and everything. And here I actually have a different document class. It's not a document, it's a resume. And so I need to specify that so that it can compile it very nicely. And there's a lot of like resources online where you can get different templates and just modify them to your liking.
Awesome. Thank you, Ale. Does anyone have any other questions? It seems like there hasn't been new ones in the chat, so if you can just raise your hand. If not, I'll give you a second. And if not, I'll ask a question. Oh, did someone say something?
Yes, I have a question, because you were doing the LaTeX example online on Overleaf, but is there a way to do it using a text file like Notepad on the computer rather than going online? I'm visually impaired, so like with R and sometimes with HTML, there might be too many links. So once I format something online, it'd probably take me up to the top again, and then I'd have to go and scroll to get to the place where I'm at. So I'm trying to avoid that. And so I wanted to ask if I could use those similar commands with a text file, like in Notepad, and then, you know, because that's how, like, I have the R file, and then I'll do like the text. Oh, sorry, my phone is reading a question. So that's basically my question. Like, is there a way, like with R, where I do base R in Notepad, is there a way with LaTeX to do the editing of documents in Notepad? Like running the code using Notepad? I guess that's my question.
I don't think you can, but that's because you need either like in my presentation I have like some links to some useful like tech compilers, which can be MikTeX, LaTeX, but yeah, so here's someone, Derek linked it in the chat to have some accessibility options. But you do need to download some like processor to your computer, because if not, like with Notepad won't work, but you can do it locally for sure on your computer. I just prefer Overleaf just because I would rather have something like online. I don't have to carry all of my documents like that if I log into a new computer, because it's an account. I will already have all of my documents there, and I don't need to struggle like finding them or knowing where they are. But I also get why you would want to run it locally on your computer. But yeah, MikTeX has some accessibility options apparently. Thank you, Derek.
Thank you. I just wanted to make sure I could run it, because I know with R, I've had to do a little bit of Python to get my output and all that. So I know, I just wanted to make sure that I could use the functions that you were showing locally. That was basically why I was asking.
Universal.
Okay, perfect.
And then we have another question. Thank you so much. Do you switch between Doc and Overleaf, or do you write the text in Overleaf? or do you have any recommendations for users who just started learning LaTeX?
So my advice and what I've done is just like start working on a project and try writing it out in Overleaf. The first time around, yes, there's a learning curve, but then as you get better at it, it gets a lot easier. And so I now mostly work on Overleaf, but I do the thing that Derek did, which is that I will generate my tables in R and then copy paste the LaTeX code into Overleaf, or I will upload my figures as PNG files and then call them. But I've gotten really used to it, and then because I don't know if it's ever happened to you that you're working maybe on a Word document and you're citing stuff, but you're just like typing out the actual parentheses and everything, and then you generate your reference list and maybe you're missing some citations, or you added like more citations that you actually had in your text and it doesn't really make sense. So the big benefit for me about using Overleaf is that it automatically keeps track of the the references that I am actually using in my text, and so it will not add any random like reference there that I never referenced in my actual text. But yeah, I will say the first time may be hard, but it gets a lot easier. And just like with R, there is a learning curve to it. Like probably at the beginning, it'll be annoying, frustrating, hard, but then as you keep using it, it gets a lot easier.
Any other questions? We have about 7 minutes left. No, that's not true. Just a couple.
Ale, I do have to Chen's point. Do you think you could show us the visual editor, like for first time LaTeX users, just so they can see like the beta version?
Oh, I don't think I have it right now. Do you have one maybe? I didn't prepare it.
I think if you go to the what you were sharing, instead of like the code version, there's like just a visual. You switch over and
I see what you mean. Yeah. Oh, for sure. Sorry about that. I thought you meant a different thing. Yes. Let me share that. And so here, I have the visual editor. And so actually, yes, you can actually edit things here. You can hide the document preamble. But here you can start playing around with different things. These commands will not compile. What I'm just I think I mentioned it as I was talking, but you can comment things out using the %. And so if you want to make like a note to your co-authors, like, oh, I don't know what this means, or you're like setting a reminder for yourself in the future, like, oh, remember to add this very important citation, you can use this % and it will not show in the actual, like in the compiled document. Something that I also think I didn't show is like, okay, so you have your compiled document and then what? You will click download PDF. And then you get your really nice PDF document that you can share. So yeah.
Any other? Oh,
Yeah.
Alex says thank you for the webinar. So, oh, and go ahead, Kenneth.
Yes. I don't know if you touched on this, but if you have, because I have my documents on Zotero and all the rest, how do you upload them to your to use them on LaTeX? I have already the bibliography, but how do you bring them in from other like Zotero and all the rest? How do you bring them in to your LaTeX file?
So the thing with Zotero is that it's very easy to generate the .bib file, and then you will just upload it to your Overleaf framework. To be honest, I don't love working with Zotero, so I don't have an actual example now, but I did guide I included a link to a guide in my slides that has just like the steps on how to do it, but it's really easy because Zotero will automatically generate the bib file for you, and then you will just upload it to Overleaf and then be able to cite from there.
I also would say I do use Zotero, and something that I do is I can be a bit lazy. So I have linked my Zotero to my Overleaf. And anytime I like add something to my Zotero, if I recompile my Overleaf document, it'll automatically update that as well. There's some it can get annoying if you're trying to do it fast, but you can also just directly sync your Zotero to your Overleaf and do it that way. So you don't even have to create a bibliography and change it every time you add a new one. So that's also an option. And there's also links for that. And I'm happy to share more too. Okay, if there's no final questions, I'll turn it back over to Bennett because I know we've got just like 3 minutes left.
Thank you. I guess just thank you to our presenters for sharing this, and thank you to the audience for attending. I'll share the recording as soon as it's ready. It usually takes us like up to 7 days. So thank you all. See you. Have a nice day.